Well, hey everyone, and welcome to the next video in the A-Star Unity tutorial series. In this video, we're going to go ahead and start displaying our grid on the screen. And let's go ahead and get into it. So go into the scripts folder. We're going to create a C# script. Call it grid behavior or grid manager controller, however you want to call it. Okay. For this to populate. Double click it, open it up, and now this will be a mono behavior. And so what we're going to do now is we'll come into here and get some variables set. First, let's go ahead. We're going to do private read only list, dictionary. It's going to be a dictionary of nodes as the key, and it'll have a tile behavior for its value. This will be called tiles, and we'll set it to a new this. So what this is, this dictionary is going to hold every node in the grid, and its value is going to be the tile behavior associated to that node. It'll be the whole map to visuals. So everything we can see that's a grid will be in this dictionary. That's what it's there for. So we'll need a private game object, which is our tile prefab. And then we're going to make it private so no one else can access it, but we do want it to be accessed in the inspector. So we're going to serialize the field. Okay. And then we're going to go and here, we're going to do private node, a two-dimensional array, call it grid. This is going to be all the nodes. Okay. And so now we need our public accessors for it. So put some space here, down here. Public dictionary node. Tile behavior. Tiles. All we're going to do is just return this dot tiles. This is just going to return the tiles. That's all it's going to do. We won't be accessing it anywhere else. So we'll do that, and then we're going to do the same thing for our 2D array of nodes. Like that. So now we got that and that. We'll go ahead and pop that down some. We're going to have to come back and do some more stuff in the future once we have our A-Star up and running. But for now, we just want to go ahead and get it drawing things. And we'll go ahead and put a public function up here as well. Node. And then we'll call it getNode. Okay, and then this will return this dot grid x y. So basically, you just give it a you're going to give it a position, and it's going to go into the grid and return the node at that position. That's what this function is for. Okay, and then on start, what we're going to do is we're going to call this dot setup grid. We didn't make it yet, and then we'll come down here to void setup grid. So what are we going to need to set up the grid? Well, what we're going to need to do here is first we're going to create an offset of 0.5. The reason we're doing this is because we want the tiles to be instantiated flush next to each other. They're not overlapping. If we don't put this offset in the instantiation process, it's going to cause issues. Just won't look right. So then we're going to do vector 3 world position equals to camera dot main dot screen to world point. Going to be a new vector 3. Going to be 0 set to screen height. That'll be our world position. Then bool walkable temporary variable. This dot grid is going to be set to a new array of a 10 by 10 grid. This is just something we're statically making it. This is just something simple to show you how the algorithm works. So that'll be that. And now what we're going to do is we're going to create a for loop, double tap tab, and it'll fill it in for you. What we're going to do is we're going to do in here, we're going to type in 10 because it's going to have an X, and then 4. And then inside of here, we're going to change I to J. And then this is also going to be 10. So we're going to have a loop inside of another loop because we're going to go and create our grid. First, what we're going to do is we're going to go and say game object, instantiate. We're going to instantiate this dot tile prefab. Okay. Now we're going to set its world position. So we're going to go dot transform dot position and set it to a new vector 3. We're going to do world position X plus I plus the 0.5 F offset. And then we're going to do world position dot Y minus J plus negative 0.5 and then 0. So what we're doing here is we're saying, hey, the X position is going to be set. So like when this is I, so this is going to be 0. So it'll be world X position 0 plus 0 plus 0.5. And it's going to say the Y position is going from the screen height. So it's going to say from the top of the screen, we're going to draw down. So we're going to subtract J. So it'll be 0, 1, 2, 3, 4. It's going to make the tiles go from the top to bottom is how we're doing it in this one. And then the offset will be minus 0.5. And then we'll close that off with the parentheses like that. And then on the next line, we're going to determine whether it's going to be walkable or not. So we'll do walkable set to I modulus 10 equal to 0 or J modulus 10 equal to 0 or I equal to 10 minus 1 or J equals 10 minus 1. And then we'll do tertiary operator false, true. And I will explain what is happening here. What I meant to do is this. Okay, I'm going to explain what's happening here. Okay, so we have a grid that's 10 by 10. So we'll do 3 by 3. Okay. So I modulus 10, when you use the modulus operator, it's grabbing the remainder when you divide a number. So if this is going to be 0 divided by 10, it's going to be 0. You do 1 divided by 10. Well, 1 divided by modulus 10, you get 1. You get, so if it's 2 modulus 10, you're going to get 2. So it's going to go all the way up to 9. Then 10 modulus 10, it's going to be 10 divided by 10, which is 1 with 0 remainder. So it's going to kick back a 0. What this is saying is I want every outer boundary to be unwalkable. I want all of these. I want all these, and these all to be not walkable because they're the boundaries. I'm setting personal boundaries. So if any row modulus 10 is 0, if it's an outer boundary here or here, we're going to go ahead and set it to false. Same thing for the j. If I is equal to the number 10 minus 1, because when you have a grid, this is a 3 by 3 grid, but the indices are actually 0, 0, 1, 0, 2, 0. This would actually be a 2. And then this down here would be 2, 2. 2x, 2y. So if this were actually a 3 by 3 grid, it would be 3 minus 1, which is 2. So it's saying, hey, everything that's on the far right or the far bottom, they're all going to be false. So anything all the way to the right and all the way to the bottom, they're going to be false. These two are saying anything all the way to the top or anything all the way to the left are going to be walkable. So if any of these are true, you're going to set it to false. If it's not, we're going to set it to true. It's going to make a lot more sense as soon as you see the visuals. We're about to show them. So we'll do that. Then we'll go into the next part. Okay. Now, what we're going to do here is we're going to create a node. Node in. Node. A node. Node is set to a new node. Give it the position of I, give it the position of j, and whether it's walkable or not. Okay, so now we created a node. Now we need to go and create a... Now we're going to go and get a reference to... We're going to go... This game object that we just instantiated, remember, it's going to already have a tile behavior component on it. So we're going to do go.getComponent, and then we're going to do tile behavior, like this. So now we've got a reference to it. We're going to say tile.node is set to the node we just created. So now it has a reference to that. And then we're going to do this.grid at position I and j is going to be set to the node we created. And then go into the tiles dictionary and add node and tile. And that's going to be it for this function. So we create an offset to make sure the tiles do not overlap. We're going to grab the world position. We're going to start drawing from the top left corner of the screen. We're going to cache a variable here. We're going to make a 2D array of a 10 by 10, which is 100 nodes. We're going to come in here and loop through, and we're going to instantiate the tile prefab, get its position. We're going to check to see if it's an outer node. If it is, or an outer tile. If it is, it's going to be set to false. Create a new node. Grab the tile component, tile behavior component. Give it the node as reference. Go into the grid and say, hey grid, this is a node located here. And then now tiles, add this to the dictionary. So when we do this, we can go back into Unity. Go here, create a new nifty game object. And we'll call it grid manager. Okay, and we'll give it the grid behavior component, and then the tile prefab is going to be assets tile. This, save it, and if we hit play, And there's our grid. So I know we can't see it in the view. So what I'm gonna do is we'll move the camera around. We'll move the camera this way, camera down. So this is our grid, okay? We created a 100 by 100 grid. This is 10 tiles, 10 tiles. But you see how all of these tiles, how let's see, where is it spawned at? Because I can fix that for the next one. Let's see, what's the camera position? So the camera position, we'll just put our camera position at 5 and then like negative 4. So we'll go ahead and just put this inside of the code so that way we won't have to move the camera. But yeah, you see how all of the outer boundaries are walkable? These tiles can now be walked on, but everything in here can. So with that being said, what we're going to start on in the next video is we're going to start working on our A-star algorithm, and then we'll come back to the grid manager script later on so we can start doing some really cool stuff. So that's it for this video. I hope you enjoyed it. In the next one, we're going to get started on the algorithm. I appreciate it. Hope to see y'all soon. Later.